Good morning, folks. Welcome back to Walter's Aircraft Works. It's June 22nd. We've been away from the shop, well, for a couple weeks now. Family vacation and work and odds and ends. I guess away from the shop isn't 100% accurate. I've just been away from the project, but I've been in and out of the shop trying to get a couple of things done, get a little bit cleaned up, get organized, and also installing a new air compressor and a bead blaster. My buddy Mike came through again with a bead blaster, and I'll show you a picture of it here in a minute, but had to install a new air compressor to get enough air to make it work properly. So it took me a couple of days just plumbing and chasing leaks, and I'm not quite 100% done, but pretty darn close, and real happy to have a new piece of equipment in the shop. Alright, so this video is all about assembly of the parts that we've built, the adapter plate, the drive coupling, and hey, we're almost there. We're getting ready to get into the real nuts and bolts of this project, slipping the motor and the transmission into the car and fabricating the motor mount. And then after that will be batteries. If anybody's got any ideas out there, I know the Tesla Gen 1 batteries are coming out on the market. It seems like it's kind of pushing the price of the batteries down. That's a good thing, but I guess I need to really start focusing on what style of battery we're going to put in the car and start making some plans for that. Alright, so today we're going to assemble these parts. I've done a little bit of prep work here. I've cleaned everything up. I've cleaned the bolts. I've cleaned the mating flanges. Started off with just Scotch-Brite sandpaper and then wiping everything down with acetone. I've cleaned the threads, and I built, well, I'll show you. It's a bracket on the back of the motor just to hold the drive, or the input shaft, to hold it still so we can torque the drive coupling on the front of the motor. Also did a little work on the transmission, just covering up these holes that aren't going to be used anymore. There's the one for the input arm for the clutch, as well as the starter hole there. Second hole here gets filled with a mounting bolt for the adapter plate. Also made, sorry for the wiggliness, made a attachment ring here to help us hoist this thing once we get it all assembled. And it gets pretty heavy. I did a little bit of math on where the center of gravity of this thing will be, and the motor is, I think, 115 pounds. The transmission weighed out to be about 78 pounds, I believe. And this attachment ring is not quite in the right place according to my calculations, but it was convenient to mount it there, and it's gonna, I think when we hoist it, we'll tend to lean transmission down, which is going to help us slip it into the tunnel of the car fairly easy. So I think it'll work fine there. If not, hey, I've had to back up and punt before. I can certainly do it again. All right, what's the assembly sequence here? Well, we're going to have to put the adapter plate onto the motor first. That hole that we machined that fits right here on this flange is not quite big enough to allow the drive coupling to pass through it. So it means we have to put the adapter plate on first, and then the drive coupling, then the spring plate, and then we can slide the two of them together. Now I've got all the hardware, the correct hardware that I want for the adapter plate and the drive coupling and the spring plate. All these grade 8 flange bolts, they're all the proper length. I'm happy with all that. The mounting flange between the transmission and the adapter plate, I still have just some CAD plated grade 8 bolts from Tractor Supply. I'm not sure I'm going to use those. Some of the lengths have changed. One of those bolts passes through my attachment ring. I'm probably going to switch those over to flange bolts as well. It's just going to take a little bit of time once we get it together, take some measurements, and then source those bolts out. They're a little bit harder to come by than a standard non-flanged grade 8 bolt, but I like them, they perform well, and hey, if I can get them, that's what I'm probably going to use. So let's get started here. Like I said, everything's cleaned and ready to go. I'm going to use Loctite on the threads. The blue Loctite, which, hey, isn't this great? Blue Loctite is in the red container, and the red Loctite is in the blue container. You know, just if you didn't have enough to worry about, Permatex and Loctite get together and try to confuse us all. But the blue is the removable. I'll probably use that on the bolts. The red I planned on using in the QD coupling as those two parts go together. A nice tight seal there. Really, I think it's more just to keep the moisture out. Got one comment from a guy about dissimilar metal corrosion, and there is that possibility, I guess. If we use this Loctite, squeeze it together, it forms a seal in there, keeps the moisture out. You can't get dissimilar metal without an electrolyte. The water becomes the electrolyte, so if you seal it, you can't get dissimilar metal corrosion. Well, we've also taken other precautions against that with sealing up the bell housing the best we can. And hey, you know, this thing doesn't have to last forever, but we'll do our best to protect it against the elements the best we can. But that was my thought process anyways, was the red Loctite. Squeeze it together, it helps with the grip a little bit and seals out the moisture. Should be in good shape there. All right, well, let's get started mounting the adapter plate to the motor. You can see I've got the torques written on each individual parts. Got the torque wrenches ready to go here. So let me change position of the camera and we'll get this thing mounted up. I'm just going to go ahead and put the adapter plate on there. Pretty nice with this little flange on here. It just slides right on and stays where it needs to stay. I'll start this bolt just to hold it, and then I'm going to go ahead and pull these out and put some Loctite on them, as we talked about. Of course, here's the blue Loctite in the blue Loctite in the red container. All right, there's that one. Took me a little bit of scrounging around to find these bolts the proper length, but finally did. Also a little bit of poking around on the internet to find the proper torque limits to go steel bolt into a aluminum flange. But as you can see, it came out to 30 foot-pounds. Oh, I'm making a mess of the Loctite. All these mating flanges were cleaned off with acetone as well and blown off with the air compressor to make sure there wasn't any dirt getting sandwiched between. You may have noticed that I installed these screws right here to help hold the three pieces together. I did that off camera as well. It was kind of cumbersome to be fumbling around with all three pieces of the adapter plate, so it made sense to kind of bolt them together. All right, 30 foot-pounds. I've got the torque wrench set at 30, but I think I'm going to back it off and bring the torque up slowly. There's 10. And I'll just use a crisscross pattern to torque them. 10's not a lot of torque. All right, and 20. All right, and finally 30. All right, that should be good. Let me reposition and we'll get started on the drive coupling. Hey, if you remember from the previous videos when we built this drive coupling, 3 of these holes in this QD was tapped. The other 3 were not. That was so you can run the bolts either way. I came up with a fix here. I wanted 6 bolts in this assembly, and I didn't know whether I was going to use larger bolts and try to tap this QD coupling. Well, what I decided to do was just make some inserts to press into the QD coupling, and then I can still use the same bolts, the same 1/4 inch, 1/4 bolts. Yeah, 1/4 bolts in all the holes, as well as the holes to press it back out. So yeah, I've already had it on there, assembled it, pulled it down tight, and it seems like it's a good fit, and that's going to be a good solution to probably wasn't a problem, but I like it better with 6 bolts in it instead of 3. So let's get started here on assembling this thing. Let's start by I think what I'll do is I'll put the red on here now. Let me get a brush. Okay, I'm going to brush this stuff around. Make sure it all gets nice and covered. Looks like I cleaned this stuff really well with acetone and air. Looks like there's something there, but well, I guess it isn't. Maybe a little bit more. Stuff is permanent, or I think they call it high strength, and it is pretty tough to break the seal on it. But if you do, if you have problems breaking the seal, you can always put a little heat on it, and that seems to really loosen it up. So I'm going to just start these bolt here and use my little finger dealio here to kind of get them started. Alright, there, that's still QD fitting is loose. I'm gonna put some blue Loctite on the shaft of this, or maybe I'll put it inside the fitting here, just to keep out moisture. Alright, so you heard it bottom out there. That's bottoming out on this aluminum piece that we turned, so that's perfect. Let's start working these bolts in. We're just going to hand snug them at this point. Still going to use a cross pattern. Just good technique. Also draws that coupling in even. Alright, pretty tough to do any more of that with my hands, so I'm going to switch to the torque wrench, and I've got it set at 80 pounds or 80 inch-pounds. It's going to 132 total, but we're going to go up slowly in increments like we did with the 4 mounting bolts. Let's see, that's not quite clicking, so I'm going to take a round, snugging these up a little bit more. That's quite a bit to draw in there. Gotta be getting close. I think we're real close. There we go. Alright, I'm going to take another round just to make sure we got them all. Alright, now I'm going to bump the torque up. Torque them at 100. Alright, now we're going to go all the way to the final torque of 132. Alright, 132. Alright, that should be good. Alright, well, I forgot to put the Loctite on the bolts while I was filming last time, so I pulled them all back out one at a time and put the Loctite on the threads, put them back in and retorqued them, and everything's in good shape here. Now, we're going to go ahead and mount the spring plate. Same process. We're going to use our little alignment tool that we made on the lathe, and I'll start these bolts and then pull them out individually and use the red tubed blue Loctite on these threads. Well, this stuff seems runnier than it should be. I'll go ahead and do these two top ones first, and then take our device loose that we have mounted on the back that holds our armature, or I guess there's no armature in this motor, it's an AC motor, so it holds our what do they call that, a rotor, and be able to spin it around. Let's see, boy, that one's a little, oh, I've messed up here. Missed the bushing on that one. Just what I didn't want to do. Alright, well, let's see. Bushing's flopping around in there. I have to get a magnet after it. There we go. Well, I heard the kitty cat. Jetson, what are you doing? I think Jetson's made an appearance in every one of these videos. It would be a shame for him to start getting shy now. Huh. All right. Tricky. There we go. A lot of thread engagement in these bolts into that aluminum. That's nice. Alright, last one here. Let's see if we can get this one in without struggling with it. Yes. getting slippery here. Okay. Things seem like it's got a heavy spot on it, because it does with that plate that I made that mounts on the back of the shaft there that helps me lock it down. Definitely made it lopsided, or one heavy spot. Alright, snugging them up. Alright, 108 inch-pounds is what the old interweb said for those bolts. Let's back it off. We'll do about 50 pounds or so. Alright, there's 50. Let me lock the back end down. Alright, that's good. Now let's do 108. Okay, those are all torqued. Now my next task, I think I want to put a dial indicator on this. I mean, there's a good sign right there. The bushing slides right in and out with no friction, so tells me it's pretty centered up. And there is a tiny bit of play there. I don't know, I'm guessing 3 or 4 thousandths of an inch, but I'm going to put a dial indicator and spin this thing through to see what kind of run out we have here. Not that this pin will be used, but it'll be a good place to dial it, to indicate it, to see how we did with this whole rotating assembly. So let me get that set up and we'll take a look. Alright, this is what we got set up. We got a dial indicator set on that guide pin, and there is a little bit of play in there, 2 or 3 thousandths worth of play on that guide pin. And when I swing the motor around, it shows about, you know, what's it showing? About 20 thousandths worth of run out in there. A little more than I'd like to see, but I think it's going to be just fine. Alright, we're going to go ahead and slide the motor and the transmission together, get them bolted up, and hey, we're almost done with this thing. Alright, with any luck, I've got this set up transmission level and the motor fairly level on this little cart, and it should roll right together. I lubricated the shaft of the transmission, the input shaft, with a little bit of lubriplate. That should keep it from rusting, keep it from you know, help it kind of slip on there, and hopefully it'll slide right together and we won't have any issues here. Let's give it a try. Turn the motor a little bit. There we go. Splines are engaged. Let's see, we got our alignment pins, or our dowel pins, to line up here. Let's see, a little bit of a turn. There we go. There we go. Alright, slipped right together. Nice. We'll put a bolt through it. Like I said earlier, these are not my bolts of choice. Temporary bolts. Hopefully I'll be able to find some flange bolts that'll do a little better job, look a little nicer in there. But right now I'll use these grade 8 bolts just to hold it together while I do some measuring and source out some flange bolts. Alright, so that should be it. It's assembled. Alright, the next part of the process will be lowering this assembly inside the car, hooking up the cross member to the engine mount here, the motor transmission mount, and then creating the motor mount that'll support the motor And remember, we a while ago talked about tying the motor mount into these lower bolts. So we'll have to create all that, and that'll span between the two original motor mounts in the car, this one and this one. So the motor will set right down in this area here, and motor mount will go from that point to that point and support the motor. This has been a fun project so far. I hope you guys have enjoyed it. I hope it's been helpful to you, and I certainly appreciate the comments and the support, and I look forward to seeing you on the next one.